Alright, so now gradient is just the slope of a line or how much a line could be steeper. It is actually represented by m having the formula y2 minus y1 upon x2 minus x1. Normally gradient are of two types, like one could be positive and the other one could be negative. So how would you know if your line is having the positive gradient or the negative gradient? If you have a line going downward like this, then it will have negative gradient. This is called the negative gradient. If you have a line which is going somewhat like this, so this is positive gradient. Alright, now let's take a graph and try to find the values. Trying to find the how do we actually find the gradient. Let's see, 1 comma 2, this part B is 3 comma 4, and we have to find the gradient of this line. M is for gradient and you're finding the gradient of line AB. So how do we do it? Again, very important thing, if you just write these coordinates in this form, that would be pretty helpful. So x1 y1 x2 y2, just substitute those coordinates in the formula and you will find it. So m of AB is equals to 4 minus 2 upon 3 minus 1, 2 upon 2 is equals to 1. So we are having the answer for the gradient of AB, which is plus 1, and as you could see in this graph, this line is going upward obviously, so that's why we are having positive gradient. Alright, let's talk about some condition for the gradient. In parallel condition, if two lines are parallel to each other, their gradients will be the same. What they mean by this is m1 should be equals to m2 if there is a line 1 and the line 2, and if they are parallel to each other, so they would experience the same gradient, which is m1 equals to m2. Let's assume if these two lines AB and CD, if they are the same, so I mean if they are parallel to each other, then they would experience the same gradient. So let's find out. M of AB is equals to 4 minus 2 upon 3 minus 1, which is 2 upon 2 is equals to 1. Let's find the gradient for the C and D also. So M of CD should be equals to 8 minus 4 upon 6 minus 2 equals to 4, should be 1. So see, the answer for M of AB is equals to M of CD. So it means that these two lines are parallel to each other. Now let's talk about the perpendicular condition for the gradient. Alright, in perpendicular condition, if two lines are perpendicular to each other, their products of gradients will be minus 1, which means m1 multiplied by m2 should be equals to minus 1. If the two lines, like the line L1 and the line L2, Alright, in this case we have two lines, line AB and the line CD. As we can see over here, this line AB, this line CD is perpendicular to AB. So let's find it by our gradient thing, if we could just prove it. So the gradient of line AB will be, we have the coordinates having the formula y2 minus y1 upon x2 minus x1. I should write here the formula first. Alright, so y2 minus y1, which is 4 minus 2 upon 3 minus 1, which is 2 upon 2 equals to 1. Now let's find the gradient for the line CD. 4 minus 3 upon 1 minus 2. Minus 3 is 1. 1 minus 2 is minus 1, which is minus 1. So let's substitute this in our equation. M1 into M2 equals 2 minus 1. So we have the answer for M1, which is 1. I will write here 1. And the answer for M2, which is CD, is, I should better write it in this form, like M of AB and M of CD. So M of AB is 1, M of CD is minus 1, which is equals to minus 1. So hence proved, if the two lines are perpendicular to each other, their gradient, their products of gradient will be minus 1, and it is proved. Now let's concentrate over a tricky question. This question is often tested in the exam when you've been given with the line's coordinates, like you know what are the coordinates of A and B, but you don't know about the coordinates of C and D, and they have given you this information that the CD line is perpendicular to AB, and you have to find the gradient of CD. So how would you do it? We actually know the formula, which says M1 into M2 is equals to minus 1. So if you know, first we will try to find the gradient of AB, which is needed in here. The strategy would be to find the gradient of one line, and by using that gradient find the gradient of the other line. Let's see how do we do it. So M of AB will be 4 minus 2 upon 3 minus 1. So 2 upon 2 is equals to 1. So we will just substitute this value of MA of B, MC of D is equals to minus 1. I will just substitute the value of M of AB, which is 1. I will substitute it here and would be able to find the gradient of line CD just by shifting this one to the right side, and it will become minus 1. So the gradient of the line CD is minus 1. This is the most important question, and you need to keep in mind they could trick you by just giving the coordinate for just single line, and they're not going to tell you what are the coordinates of the other line which is perpendicular to this line.